Alright, let's look at the practice exam 2, problem number 11. Alright, so we want to set up a double integral for the volume of the solid bounded by the graph. So we take this as a surface. I should have said a little bit more. We want it to be the solid above the z equals 0, which is the xy plane. Right? And then the region is bounded by y equals x, y equals 0, which is the x-axis, and x equals 4. Right? So let's draw the two-dimensional region on the xy plane. Alright, so the region looks like this. Alright, so on the xy plane, alright, then let's see, y equals x, so that's just going to be a straight line, and with slope 1 going through the origin. So this is the straight line, right? So this is y equals x. Right, and y equals 0, that's the x-axis right here. Right, and x equals 4. So x equals 4, so let's say here, let's say this is 4, then that will be a vertical line there. So we have x equals 4. Alright, so we are looking at this region right here. Alright, then there's a surface above this. Right, the surface is defined by this equation right here. So I'm going to solve this equation for say z. Right, so it's a z squared is equal to, so by subtracting x squared, we have 16 minus x squared. Right, by taking the square root, z is going to be, and a plus or minus, but I'm going to take only the top one, so it's going to be a plus square root of 16 minus x squared. Alright, so we can set up an integral this way. So the volume V can be found by double integral. Alright, so then the surface is that z equals square root of 16 minus x squared. Right, and I'm going to do with respect to y first, then with respect to x. Right? Alright, so we're going to fix x, since we're going to do the integral with respect to y first. We're going to fix x. So if you fix x here, right, you can see that y is going to go from y equals 0 to y equals x. So here's y equals 0 to y equals x, because that's the equation of the line. So it goes from 0 to x. Right? Then x is going to go from, so to swipe the entire triangular region, x is going to start from 0, then go all the way to 4. X equals 4. Right? So x is going to go from 0 to 4. Right? So this is the double integral for the volume of the solid described above. Alright, that's it. I hope that this was clear.